Hi everyone, this is your video on parallelograms, the introduction to parallelograms. So, at any time you can always pause this video to write something down, or you can rewind it to watch something again. So, a parallelogram is a quadrilateral with a set of two parallel sides. A quadrilateral, we know, is a four-sided figure. So, these two sides are parallel, and these two sides are parallel. That's what it means to be a parallelogram. So now we're going to do a proof. So we have that there's two lines. We're starting with that the opposite lines are parallel, and we're trying to prove that the opposite sides are congruent. So what I'm going to do is first I'm going to say I know that angle 2 is congruent to angle 1. Angle 4 is congruent to angle 3. Because the goal here is I'm actually going to prove that these two triangles are equal, and then use CPCTC to say that this is equal to this and this is equal to this. So we know two lines are parallel if and only if alternate interior angles are congruent. Okay, so then I can just use GE is congruent to GE. With the reflexive property, and I've got that GFE, triangle GFE is congruent to triangle EHG. That's angle side angle. And then I can just say so that last step I just used CPCTC to say the proof statement. Opposite sides of a parallelogram are congruent. So we are allowed to say that if we know something's a parallelogram, this side and this side are equal, and this side and this side are going to be equal. They don't all equal each other, but the opposite sides are equal. We're also going to be able to say that opposite angles of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. And don't forget, you can always pause this at any time or go back and watch something else that you didn't catch. Opposite angles of a parallelogram are congruent. All right, now I'm going to prove something new. I'm going to prove that AC and BD bisect each other. Now, whenever you see this symbol right here, that means parallelogram. It's the only quadrilateral we use a symbol for. The other ones you have to write out. Like if you have a square, you have to write out the word square, A, B, C, D. But with a parallelogram, we can write the little parallelogram sign, and that means it's a parallelogram. All right. So basically what I want to do is I want to prove that M is the midpoint of both of these lines. I want to prove that DM equals MB and AM equals MC. So again, I'm going to use congruent triangles. I'm going to try to prove that these two triangles are congruent. The first thing we know is that AB is parallel to DC, right? That's the one that I'm really going to need. And we can say opposite sides of a parallelogram are parallel. That's what tells us that. Which then opens the door to saying angle 3 is congruent to angle 2, angle 4 is congruent to angle 1. And that's two lines are parallel if and only if alternate interior angles are congruent. Okay, so now I've got this. Okay, because I know this is a parallelogram, I also know that AB is congruent to DC because opposite sides of a parallelogram are congruent. Okay, so then I know that these two sides are equal. So I can actually say now triangle ABC is congruent to triangle ABM. Is congruent to triangle CDM. And that's angle, side angle. Now I can use CPCTC to say that DM is congruent to MB and AM is congruent to MC. And we can say that they bisect each other. A bisector divides a segment into two congruent parts. We know the rest. You just have the whole. I can't fit it here, but that's okay. All right, so this actually gives us a theorem. The diagonals of a parallelogram bisect each other. The diagonals of a parallelogram are not necessarily congruent, but we know that they bisect each other, meaning they cut each other at their midpoints. The diagonals of a parallelogram bisect each other. Okay, so we're just going to do a little practice. We're told this is a parallelogram. We just want to find x, y, and A and B. So, oops, stuff got cut off here. This is supposed to be 9, and this is supposed to be 6, and this is supposed to be A. Okay. So, this is pretty straightforward. X and 80 are opposite, so they're going to be the same. 9 is going to equal B because those are opposite, and A is going to equal 6 because those are opposite. Now, why? What you have to remember is that in a parallelogram, consecutive angles, consecutive means right next to each other. Consecutive angles, like X and Y are consecutive angles, they're always supplementary. Because think about it. The angles of a quadrilateral have to add up to 360. So we know if these two are both 80, and I take 360 minus 160, that's 200. That's 200. These have to be equal, so I have to divide 200 by 2, and that's what I get. So what I know is that x plus y will be 180. 80 plus y will be 180. Y equals 100. All right, everyone. Thanks for watching.